Hey everyone, and welcome to This Explainer. I am so excited you're here. We're going to explore something that covers most of our amazing planet, the ocean. But here's a little secret. Ocean water isn't exactly the same everywhere you go. Some places are like a warm bath, others are freezing cold, and some are way saltier than others. Today, we're going to look closely at these differences and see how they actually control our world's weather and help marine life survive.
So here's our game plan for today. We'll start with ocean water temperature, then figure out what salinity actually is. After that, we'll compare the different oceans, talk about why all of this matters, and wrap up with some really fun facts. So, is all ocean water the same? Let's dive right in. I want you to imagine you're swimming in a sunny, tropical ocean. The water feels incredibly warm, right? Now imagine dipping your toes into the water right next to a giant, freezing iceberg. Does that water feel the same? Or taste exactly the same? No way. Our oceans are super diverse, and these differences are actually the hidden engines driving our entire planet. First up, ocean water temperature. Just how warm or cold is it? There are four main things that change how warm or cold the ocean feels. First is latitude. That just means where you are on Earth. If you're near the equator, the water gets lots of sunlight and is super warm. But if you're up near the poles, it's freezing. Second is the season. In the summer, the ocean surface warms up, and in winter, it cools down. Third is water depth, which is just how deep you dive. And fourth, ocean currents. Think of these as giant rivers moving warm and cold water all around the globe. Now, the sun shines down brightly, but its energy only heats the very top layer of the water. The deeper you go, the darker and colder it gets, simply because the sunlight just can't reach down there. It's literally a completely different world underneath the waves. Let's look at exactly how cold it gets. The top surface layer is nice and warm, usually between 22 and 30 degrees Celsius. But as you dive down into the middle layer, it drops to between 10 and 20 degrees. Go even further into the deep water, and it's a chilly 5 to 10 degrees. And down in the deepest water, completely hidden from the sun, it's a freezing 2 to 4 degrees Celsius. The temperature drops so dramatically the deeper you go. Moving on to our next topic. What is salinity? It's the secret hidden right there in the water. Okay, so understanding this definition is absolutely crucial. Salinity simply means the amount of dissolved mineral salts found in 1 kilogram of seawater. You know when you accidentally swallow a little bit of ocean water at the beach and you taste salt? Well, salinity is just how scientists measure exactly how much of that salt is mixed into the water. Scientists measure salinity using a special symbol that looks a bit like a percent sign, but with an extra zero. It means parts per thousand. The average salinity of the world ocean is 35 parts per thousand. To put that into perspective, if you take exactly 1 kilogram of average seawater, it holds about 35 grams of dissolved salt. So let's see how natural processes actually change this saltiness. Evaporation happens when the sun heats the water, turning it into gas. The water disappears, but the salt stays behind, which increases the salinity. Forming sea ice does the exact same thing. The water freezes, but the salt is left behind in the ocean. On the flip side, heavy rain, rivers flowing into the sea, and melting ice all add fresh water to the ocean. When you add fresh water, you dilute the salt, and that decreases the salinity. Now for part 3, comparing the oceans. Let's take a quick trip around the globe. When we look at average surface temperatures on a map, the red and orange colors show us the warmest waters, while the blue and white show the coldest. Look right there in the middle at the Indian Ocean. It's mostly red and orange because it sits in hot tropical latitudes. That makes it the warmest ocean on Earth. Now look all the way up at the top. The Arctic Ocean is white. A huge part of its surface is covered by ice all year round, making it the coldest ocean by far. Now let's compare salinity, or how salty the water is. On one hand, we have the Atlantic Ocean, which is actually the saltiest ocean in the world. This is because of strong evaporation from the sun and less fresh water coming in. But then look at the Arctic Ocean. Not only is it the coldest, but it's also the least salty ocean. Why? Because constantly melting ice and huge rivers flowing into it are always adding tons of fresh, unsalty water. So why does it matter? Let's talk about the moving ocean. Okay, this right here is the golden rule of the ocean. Temperature and salt change how heavy the water is, which scientists call density. It's actually really simple. Warm, less salty water is lighter. Because it's light, it floats up and rises to the surface. But cold, saltier water?
That water is heavy, and because it's heavy, it sinks straight down to the bottom. Let's see how this builds into something truly spectacular. Step 1. Temperature and salt change the water's density, making it heavy or light. Step 2. Because of this, massive amounts of water are constantly rising to the top and sinking to the bottom all over the globe. Step 3. This continuous sinking and rising creates giant ocean currents. These currents act like enormous invisible rivers under the sea. They move heat all around the Earth, control our weather, and carry nutrients that marine life absolutely needs to survive. The ocean is basically a giant global water pump.
Finally, fun facts and summary. Let's review what we've learned.
Did you know that ocean surface temperatures can drop all the way to -2 degrees Celsius in the polar regions? Now, you might be thinking, wait, doesn't water freeze at 0 degrees? But here's an amazing fact. Seawater actually freezes at a colder temperature than freshwater, simply because the salt gets in the way of the freezing process. And speaking of that salt, what exactly is it? Well, 85% of the salt dissolved in the ocean is sodium chloride. Does that sound familiar? It definitely should. Sodium chloride is the exact same type of table salt that you might sprinkle on your food at home. To wrap things up, here are the main ocean rules to remember. Warm water loves the equator, while cold water stays near the poles. The Atlantic Ocean is the saltiest, and the freezing Arctic is the least salty. And the biggest takeaway of all? Temperature and salinity work together to make water heavy or light. This creates those giant moving currents that control Earth's climate and help our amazing marine life thrive. The ocean is literally never still. It's always moving, flowing, and shaping the world we live in. Understanding its temperature and salinity helps us understand our beautiful, complex planet. So, stay curious, keep exploring, and ask yourself, where will the ocean currents take you next? Thanks for joining me for this explainer today, and I'll catch you next time.